This is the FlashForge Photo 8.9. Unlike the usual FDM or fuse deposit modeling 3D printers that I usually feature on this channel, this machine uses liquid resin which is cured layer by layer with UV light. For many, including myself, FDM printers are more than enough for the everyday project. They're quick, they have a large build volume, and they're pretty straightforward once you get the hang of it. So why in the world did I get a resin printer? Well, this is gonna be a long story. So, let's start from the beginning. Now, if you're anything like me, I'm sure you've at some point scoured the internet in search of a new set of headphones that supposedly sound better than the old, broken ones that you've had for a while. You look for good prices and stumble upon some sets that seem ridiculously expensive, like,
wow, can they really sell those things for $250 a piece?
So you end up buying a pair of AirPods Pro, and oh boy, do they sound good, like, really good. You listen to all your music on them, take them everywhere, but in about a year, you start to get curious. You wonder if personal audio could get any better, or if you should just stay content with Apple's Pro offering. But one day, you decide to venture into the world of IEMs. You find a set called the CCA CRAs on Amazon for only $15. It's worth a shot, you say. But when you first put them in your ears and hit play, you are delightfully surprised. Not only do they sound great for their price, they sound even better than the AirPods Pro that you bought for $250. All of the small nuances of the music can be clearly heard. The music sounds like it's enveloping your head, and the bass feels textured. And so the discovery continues. You begin researching IEMs. What even are they? Who uses them? Why do they sound so good? And wait, hold on. Someone's charging $2,000 for a pair of wired headphones? Yeah, and that's how I worked my way up to buying a set of wired IEMs for the cheap price of $300. But hold on, that's not what this video is about. This video is about my gift, in a sense, to you, my viewers. As you might be wondering if you have not already delved into the audio equipment world, IEMs, or in-ear monitors as they're commonly known, have traditionally been used by musicians on stage to clearly hear special cues in instruments or vocals. As time has gone on, consumers have noticed that the pure sound quality delivered from these IEMs is incredible. Later on, companies based in China began offering their own IEMs aimed at the consumer price bracket. This, as is evident online, has completely blown up into an entire industry. Audiophiles, who are basically just cranky people who will only listen to their music at the highest fidelity and will get unreasonably angry whenever someone challenges their tuning preferences, took notice all around the world. Innovative technologies started showing up at multiple price brackets, which only added fuel to the fire. But since the world of audio equipment is incredibly vast and difficult to explain in only one video, I highly encourage you to go read up on the history of consumer audio equipment. There are multiple resources online that will explain things way better than I will ever be able to. Up until this point, I had only really bought my IEMs from other companies, CCA, KZ, Canera, The Audio, Panon, and I was very impressed with most of them. But still, for some reason, or maybe it was just simply because of the smoldering hole left in my wallet, I made up my mind that I wanted to build my very own IEMs, for cheaper, just the way I wanted. After reading online for a bit and watching Jeffrey from Hi-Fi take apart $100 IEMs, I was absolutely thrilled. I eventually settled on a hybrid design which, if you don't know what that is, uses multiple drivers or speakers to produce certain frequencies. By combining certain types of drivers of various sizes and specifications, one can produce incredibly accurate and detailed sound signatures that a single driver cannot. So, what type of drivers did I choose? One 10mm dynamic driver for bass, 2 Knowles balanced armature drivers for mids and treble, and 1 Knowles balanced armature for ultra high treble. With these 4 drivers combined, I, after doing some intense research, decided that this combination would give me the sound signature that I was after. So, by this point in the video, I bet you're probably wondering why I started talking about a Resin 3D printer, and here's where that comes in. You see, high-end in-ear monitors of today only really use 2 different constructions. Either you mill out the parts from a solid block of aluminum, or you 3D print your shell out of resin. And because CNC mills are outrageously expensive, I chose to go the route of 3D printing everything. Plus, I really have a love for clear audio equipment for some reason. So I went online in search of some good discounts on resin 3D printers and stumbled across FlashForge, which amazingly offers second-hand machines for ridiculously low prices. In fact, I only ended up paying $50 for this thing. Yeah, its power supply was toast, but that was no issue at all because I just so happened to have a laptop power supply that worked just fine. After messing around with the Photo 8.9 for a day, I was actually quite impressed with the level of quality that it produced, which would be perfect for the intricate details of an IEM. With that step out of the way, it was time to begin designing the IEM itself. For this next step, I used a mix of CAD programs, Onshape and Tinkercad. Onshape was used to mock up the outer IEM shell, which was very heavily inspired by the work of this guy on Thingiverse, and everything inside the IEM, including the driver slots and tubing, was modeled in Tinkercad. Once I had finished my first design, you would probably think that this meant that my work here was done. Time to throw a set together and listen to some music. But no, that's far from the truth. In fact, leading up till now, I have gone through well over 100 shell revisions. There were so many aspects in my design that had to be constantly tweaked, and if you were to compare my first revision to my current revision, there would be very little in common. Even still, with a fully completed shell design ready to 3D print, I still had to tune the electronics. After all, nothing's going to sound good if the drivers are producing too much of certain frequencies. The drivers must be selectively tuned to only produce the wanted sound signature. And with 4 total drivers in each earpiece, there was a lot of tuning to be done. As there is a ton of information that goes into the tuning of IEMs, I'm only going to focus on 2 of the most important aspects: frequency response graphs and selective frequency dampening. To begin, let's briefly talk about what a frequency response graph is. In short, it's a visual representation of how in-ear monitors, or any audio gear for that matter, respond to different frequencies within the audible range. So on the graph, you've got a horizontal and a vertical axis. The horizontal axis measures the frequency in hertz, and the vertical axis measures the amplitude or volume level in decibels. With these combined, you've got an accurate representation of how a set of headphones will sound. Is it extra bassy? Does it have a lot of sparkle in the upper treble? Or is it really sibilant or undetailed? A frequency response gives a good idea of all of this. Pretty neat, right? Alright, so how do we measure the frequency response? Well, at least in my case, I bought this, an IEC 711 coupler. You can think of it as a weird microphone that simulates what a human ear can hear. By using this and a program called Room EQ Wizard, we can produce fun little squiggles that are surprisingly useful once you know how to interpret them well. Once I had all of this somewhat figured out, huge thanks to Delta Fire for helping me get everything set up, by the way, it was time to begin tuning the IEMs. And that leads us to the second aspect: selective frequency dampening. By using thin meshes of various materials and densities, one can effectively filter out unwanted frequencies produced by a driver. Think of it like strainers. The larger the holes, the more it can pass through. If you want to strain water out from a bowl of spaghetti noodles, you don't need a very fine strainer. In the same way, we can equate higher frequencies to larger noodles. They are much easier to filter out, as the strainer's holes can be fairly large. So higher frequencies will be muted quite quickly the more dense the filter is. On the opposite side of the spectrum, you've got bass frequencies. They are much less affected by dense meshes compared to high frequencies. In this way, a driver's sound output can be focused to create a certain frequency. Because of all of this, the tuning process has definitely been the most time-consuming part of this project, but to make a very long story short and keep this video a reasonable length, I'm going to have to cut out most of my trials and errors for the sake of time. I will, however, highlight a couple of those trials and errors. The first trouble that I ran into dealt with bass quantity. The mid and treble frequencies were smooth and sparkly, but for some reason I just could not get any decent bass response out of the 10mm dynamic driver. It was like it wasn't even doing anything. So after trying two other types of drivers, a 6mm DD and a 9mm DD, I still got nowhere. Thankfully, after over 2 months of dead ends, I figured out what the problem was, and it made me feel really dumb. The driver wasn't able to build up any sound pressure because it wasn't fully sealed with glue. Air was just being forced out the back of the shell instead of going through the nozzle. And once I figured that out, I actually had way too much bass. So from there, it was only a matter of venting excess bass and dividing the frequency the best that I could. Another issue that I faced early on was with excessive treble spikes. This was solved later on with the use of a bit of tuning foam, so yeah, pretty straightforward. Aside from this, the overall design process naturally just took a lot of time and dedication, but by early February, I had an FR graph that I was pretty happy with. They have an overall fun and warm signature with rumbling bass and velvety vocals, but also retain that sparkly, detailed percussion in the upper treble frequencies that audiophiles adore. After over 5 months of hard work and dedication, I had finally achieved what I originally set out to do: design my own hybrid IEMs which look gorgeous, compete with other IEMs at and above its cost, and learn a whole lot along the way. So, this is it, my gift to you, the Symphony Ears Tetrad Mark I. If you'd like to see more videos like this in the future, please do consider dropping a like down below and sharing it with your friends. If you'd like to show even more support, consider becoming a subscriber so that you don't miss any of my other uploads. Good luck out there, and keep building things.